Good morning, everyone. So just a quick announcement, your tests will come back tomorrow. So if you have any friends who aren't coming to class, ask them to come tomorrow so they can pick up their test. So they will be done for tomorrow morning. The topic of today's lecture is the enumerated types. So on cue, I guess before this morning, this set of slides was struck out. So it said we weren't covering them. That's because I copied the OnQ site from last term, where we were behind for some reason by quite a few number of days. But this term we're on pace, so I've decided that we can in fact cover this topic. So I hope to get through this set of slides and start the next set of slides in today's lecture. All right, so enumerated types. So consider the following groups, or I guess types of classes that you might consider implementing. Right, so something like the days of the week, so Sunday through Saturday, the months of the year, the suits in a standard deck of playing cards, right? So hearts, diamonds, spades, clubs, right? The ranks, so 2 through ace, and all these other things as well. So they all have something in common, even though they seem very different, right? And the thing that they have in common, well, most of them do anyway. Some of these are suspect, so Canadian coins, the provinces and territories, and the planets of the solar system, they may not necessarily they may not necessarily have these things in common. But the thing that they appear to have in common is that they all represent sets of constants. So the days of the week, there's only 7 days of the week, right? And that's probably not likely to change anytime soon. Right. Similarly, with the months of the year, there's only 12 months of the year. Again, probably not going to change anytime soon. Right, playing cards. Right, the coins are interesting because they do change occasionally. Right, so we don't use the penny anymore. Right, possibly in 20 years, we may no longer be using the nickel. Right, and so on and so on and so forth. So maybe not necessarily a set of constants. Right, they may change with time. Similarly with the planets. Right, Pluto occasionally is a planet, and then sometimes it's not, right? So currently it's not officially a planet, but that might change in the future again, who knows, right? But the idea is that all of these types represent a fixed set of constant values, right? So this turns out to be representing a fixed set of constant values where the constants are related to one another. Turns out to be a somewhat common thing in programming. So the way that we used to do this in Java was that if you wanted to represent a fixed set of constants, you would make some constants, right? And we just talked about how you did that, right? You make a public static final field in a class somewhere, right? And you give it a name and a value. And so it used to be common that you would use ints to represent your constant values, right? So Sunday would be one of your days, right? Monday would be one of your days. Tuesday would be one of your days. Right, and you just give them a different constant value, right? 0, 1, 2, up to 6 in this case. Right? Similarly for the months, right? So January, February, March, and so on, you'd number 0 through 11. Possibly 1 through 12, depending on how you decided you wanted to choose your constant values. Right? And so older style Java code would look like this. C code still looks like this. So C doesn't have a proper enumerated type. It has something that looks like a proper enumerated type, but it's not. So you would use integers or int values to represent your constants. In code, it looks exactly like you would think it looks exactly like what you would think it would look like. Right? You would make a little utility class. Right? So here I have my int enums class. Right? Utility class, so everything's going to be static. It has a private constructor. Right? And there are your constants. So it looks exactly the way you think it would look. I even have a method in this class, right? So I have a method here that prints, and it looks like it wants to print a day, right? And you can see right away what the problem is, right? What is the type of the parameter? Well, it's an int, right? Because my constants are all ints, right? They're the int values 0 through 6, right? And so right away, you should recognize that somebody can pass in any int value here, right? They could pass in minus 134, for example, right? And the method will accept it. Well, the method will compile anyway, right? And so now you have the problem where you have to check is this a valid day? Right, so you're going to have some giant if-else-if statement. In this case, I've used a switch statement, which I haven't shown you how to do, but a switch statement is basically a big if-else-if statement. Right? It's not important that you know how to write one of these. Right? If you want to know how to write one of these, just look it up. But basically, I'm going to, if the day is Sunday, right, I'm going to print the string all caps Sunday. Right? And if the string is, if the value is Monday, I'm going to print the string, right, all caps Monday, and so on and so on and so on. If I get an unknown string, I have a problem here, right? So if the string doesn't correspond to one of my days, I have to do something. Here I've chosen to simply print out the string unknown. Right? You might choose to throw an exception instead, right? But you have to do something, right? So you have to take care of the case where someone passes in an invalid day, right? And again, so if you pass in a valid day, so for example, if you pass in, say, Tuesday, right, and run that, right, you get the correct output, right? It prints out Tuesday. But again, you can clearly see the problem, right? There's nothing stopping anyone from passing in, say, a month, right? So the month of January apparently prints out as Sunday. Why? Because January also has the value 0, right? And so as far as the method is concerned, right, Sunday is just the value 0, so we end up printing out Sunday when you pass in January. Right. The other, right, okay, so there we go. All right, so that's the problem with using these old style enumerations, right? So when using an int to represent a constant value is problematic, right? There's no type safety. There's nothing what we call type safety, or there's a lack of what we call type safety, right? And so the method that takes in a month or a day takes in an int, right? And so it will accept any int value, right? And then it has to validate that value, which is annoying, right? It would be nice if you wrote a method that when that method that requires a day, it only takes in one of the 7 days of the week, right? So for example, there's no way to restrict a parameter to be only a day or only a month if you're using ints, right? And you can do other weird stuff as well, right? You can take January and add it to Sunday, right? They're two ints, so you'll get an int value as a result, right? And I can even compare them, right? Because they're int values, I can compare them, I can do less than or greater than on these values, which might be useful, right? So you might want to sort the days of the week, and you might want to sort the months of the year, right? So that actually could be useful. The problem is with the int style enums, you're stuck with less than, greater than, and equal to. Right. There's another problem, right, which the method I showed you illustrates. Right? If I want to print out a day, right, it's kind of gross, right? I need a big if statement that has 7 cases in it, or a big switch statement that has 7 cases in it. 8 if you count the case where you don't know, where the value that was passed in is not valid. Right? So there's no nice toString method that can convert a day or a month into a string. Right? Okay, we can fix the last problem. Right, the last problem you can easily fix. Instead of using ints, you can use strings for your constants instead. And so this is the string enum pattern. Right? So instead of using ints, I'm just going to use strings. Right? So the string all caps Sunday is just the day corresponding to Sunday, is the constant, sorry, corresponding to Sunday. Right? And the string all caps March is the string corresponding to March. Right? But you run into the exact same problem. Right? Yes, you can print out your constant now very easily, right? It's just a string. But there's still no type safety, right? The method takes in a string. A method that expects a day will take in any string. So now you have to validate the string, right? It's also true that programmers are very lazy, right? And so if you create a string style enum, right, programmers will suddenly just use the constant and the literal instead of using your named constant, right? So instead of writing month.Sunday, people will just write the string Sunday in their code all over the place, right? And now if you later on you decide that you're going to change the representation of your constant, that's a problem, right? Also, if you want to sort, or if you want to compare 2 days for equality, right, you now have to compare 2 strings for equality. And that's quite slow compared to comparing two ints or two references, right? To compare two strings for equality, you have to look at every character in both strings before you can decide whether or not they're equal. Right? Whereas comparing two ints, you just compare the two int values. Right? All right, so surprisingly late in the language, so in version 5 of the language designers added a proper enumerated type. Right? And so Java calls these enums. Well, most programmers refer to enumerated types as enums instead of saying enumerated type. Right? So enums in Java are actual classes. Right? And so if you make an enumerated type in Java, it actually inherits from this class called big E enum. Right? And so this class big E enum provides you with some methods that will operate on your enumerated types for you, which is nice. All right, so the Java's enumerated types are actual classes. Right? And so that means your enumerated types can have fields and methods. Right? So your constants can have data, which is an interesting thing. Right? And they can also have methods, which is also interesting. Right? Or potentially interesting anyway. They also have constructors, but the constructors are private, so they're not accessible to users outside of the class. Right? You don't want the constructors to be usable outside the class because these things are supposed to be constants. Right? And there's supposed to be a limited number of them, a fixed number of them. So you don't want to let somebody make an arbitrary constant using your type. Right? And so the nice thing about the enumerated types in Java is that they're very easy to use. Right? So if you want an enumerated type that corresponds to the days of the week, right, you make a class called day. Now instead of using the word class, you use the word enum to tell the compiler that this is an enumerated type. Right? So public enum day, right, brace, brace, and then you just list your constants out in the order that you want them to appear, right, or in the order that you want to compare them in. And so each one of these things here is just the name of a variable or the name of a field that corresponds to a constant day. Right? So all caps Sunday is the name of a day object, corresponds to the day Sunday. Right? All caps Saturday is the name of a day object that corresponds to the day Saturday. Right? So super easy to use. Right? How do you use them? Well, I mean, that's the name of the class. Right? These are the names of your fields. So day.Thursday is the day that is the day object that corresponds to Thursday. Right? You can even print them out. You don't have to do anything. Right? You don't have to do anything special. There's a two-string method for you provided for you when you create your enumerated type. Right? So that'll actually print out the name. Whatever string that is will get printed out here. Right? And you can even override this if you want to. Right? So if you decide that you don't want to print out all caps Thursday, you want to print out something else, right? All you do is override toString, and then you can have a different string. You can have a different string computed when you call toString. All right, so when you write this sort of thing here, the language guarantees that there is exactly one object that corresponds to the day Sunday. There's exactly one day object that corresponds to the day Monday, right? And so on and so on and so forth, right? So the language guarantees there are exactly 7 day objects, right? Sunday through Saturday, right? So there's no two objects equal to Sunday. There aren't two different objects equal to Sunday, right? There aren't two objects equal to Monday, right? There's exactly one object equal to Sunday. There's exactly one object equal to Friday, and so on and so on and so forth. So exactly one object for each one of your constants, and that means you don't have to use equals to compare them for equality, right? You can use equals equals or not equals, right? If there's only one object corresponding to each day, right? That object always has the same address, right? We know that equals equals or not equals uses the address of the object to determine whether or not they are equal, right? So you don't have to use equals anymore when you compare the enumerated constants. Right? You can safely use equals equals or not equals. If you want to, you can still use equals, right? And it does the exact same thing as equals equals here. Okay, so immediately when you use an enumerated type, you automatically get type safety, right? So where's day? So in day, we've got 7-day objects, right? Their type is big D day, right? If we make a month enumeration, right, we now have 12 month objects and their type is big M month, right? So there's no way that I can write a method that takes, that requires a day and have a user pass in a month, right? The compiler won't even compile that, right? So now you have methods that are type safe, right? A method that requires a day only accepts day objects, right? A method that requires a month only accepts month objects. So that's nice, right? So now we have type safety, which is very nice. Right? You get all sorts of other benefits as well, right? You automatically get a compare to method for your constants. Now the problem with this is that you get one whether you want it or not. So sometimes you don't want these things, right? Sometimes you may not want a compare to method. You get one anyway. Right? So the order, or the way that compare to works, is it looks at the way you listed your constants when you created your enumerated type. Right? So here we have January 1st and December last. So January is the quote unquote smallest month, right? And December is quote unquote the largest month. Right? February is greater than January, March is greater than February, and so on and so on and so on. Right? Unfortunately, so if you have no choice in this, in the way that compare to gets implemented for you, right? So there's no way for you to override compare to in an enumerated type. Right? So whatever order you want your objects to compare in, that's the order that you have to list them in. Compare to also returns the difference between two objects, right, as an integer value. So here's Monday and Thursday. Right? So if I compare Monday to Thursday, Thursday is 3 days. Sorry, Monday is 3 days ahead of Thursday. Right? So when I compare Monday to Thursday, I get -3. Right? Saturday is 5 days after Monday. So when I compare Saturday to Monday, I get 5. Right? And of course, Thursday is equal to itself. So when I compare Thursday to Thursday, I get 0 for compare to. Right? So compare to is implemented in a way such that it basically takes the difference between the positions of the two constants. All right, so you have to remember that enumerations are in fact classes, which means they can have data, right? So they can have fields. You also have to remember that these things are supposed to be constants. So the data that your constants have, those should also be constant values, right? So there's nothing in the language that requires this to be true. So you could make an enumeration where the fields have variable values, right? In other words, they're not necessarily constant. But you should remember that these things are meant to represent constants. Right? Okay, so it's a bit weird that the way that you if you want your enumerated types to have fields, it's a little bit weird the way that you list your enumeration, your constants. Right? So here's the month enumeration again. I'm now going to add a piece of information to each constant. Right? The piece of information I'm going to add is the number of days for each month. Right? So remembering that these things are supposed to be constant values, right? I'm going to mark my field as being final. Right? So in other words, I can assign the number of days once to each constant, which is problematic for February, but we'll deal with that in a second. Right? So when you have a enumerated type that has a field, when you list your constants, you have to call a constructor. So January round bracket, and I'm going to pass in the number of days for January. Right? February round bracket, I'm going to pass in the number of days for February. Right? This means somewhere there has to be a constructor, and your constructors have to be private. So it doesn't matter what you mark. You can either mark this as being private, or you can leave the access modifier off. Right? If you try to make it public, the compiler won't compile your code. Right? So your constructors have to be private. So there's my constructor for month that takes in the number of days, and it simply assigns that number to days. You really should, you can consider validating that value, the number of days here, but you don't have to in this case. Right? It's private. No one else can call this constructor. So as long as you're careful here, right, when you set the number of days, you don't have to worry about the number of days being invalid. Right? The only one that can set this is the creator of the class. And so you probably don't have to validate that value there. Right? Okay, now how do I get access to this field? Right, so how do I get access to that thing there? Or how do I give access to other users of the class? Right, well, you just provide a method that returns the number of days. Right? So because February has 29 days if it's a leap year, right, you might consider providing a days method that takes in the year. Right? So here, if the month is not February, you're just going to return the number of days stored in the field called days. Right? If the month is February, you now have to determine whether or not this is a leap year. So if the year is a leap year, I'm going to return the number of days plus 1, which is 29 for February. Right? Otherwise, I'm just going to return the number of days, which will be 28 for February. And so there's an example of providing a field, a constructor, and a method for an enumerated type. Right. Okay, so you get a bunch of other stuff when you make an enumerated type. You get it for free. So you get a static method called values. So values returns an array of the constants in the order that they were declared. Right. So in other words, right, when I make my month enumerated type, I get a static method called values. Right. So I can write month.values, and that gives me an array. Right? And it gives you an array of the constants. So it gives you an array consisting of the constants January through December. Right? When you print the contents of that array, right, you get the strings January through December. Right? So you can iterate over your constants as well using this method. Here's another example of using this method here. So month.values is an array containing the constants belonging to month. Right? I can write a little for each loop, right, that iterates over all the months. Right? So for each month m in all of the months, right, I can now ask, hey, how many days are in the year 2018? Right? And that's going to print out 31, blah, 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 blah. Right? Oh, there you go right there. Right? And of course, if you picked a leap year here, you'll get the exact same thing, except February will print out 29 days instead. You also get a static method called value of that takes in a string. So value of lets you convert a string to one of your constants, which is also handy, right? So for example, value of and then the string May will return the constant corresponding to the month May. Right, so you can convert, so using enumerated types, you can easily get the string corresponding to the enumerated type, right? And you can convert a string easily to one of your enumerated constants. Right? So value of string May gives you back the month May, right? Which is handy sometimes. Right? And now for something that's very weird. So we haven't seen this yet. And we're going to see this a little bit later on in the course, so probably in 2 or 3 weeks, probably 2 weeks. We're going to see more examples of this. So each one of your enumerated constants is allowed to have its own version of a method, which sounds really wacky, but that's the language lets you do this. Right? So for example, the month January can have a method called something, right? And the month February can have a method called the same thing, but it does a different thing than the month January. And so this is really weird, but this is the way, it's one of the features that enumerated types lets you have. Right? All right, so to do this, if you choose to do this, you declare what's called an abstract method in the enumeration. Right? And then you replace the definition of the abstract method for each one of your constants. So we're going to learn more about this when we talk about inheritance. So let's look at an example of this in play. Right? So I'm going to make an enumerated type that represents the different arithmetic operations on a calculator. Right? So addition, multiplication, subtraction, and division. Right? So here's my enumerated type called operation. Right? So these represent basic arithmetic operations. Right? So imagine you're implementing a calculator, for example, right? A simple calculator. Right? You pick your arithmetic operations that you'd like to provide. Right? So for a very simple calculator, we're going to have addition, subtraction, multiplication, and division. So I have 4 constants that correspond to the different operations. Right? So for plus, I would like to add 2 values. Right? In this case, 2 double values. Right? So I'm going to provide a method called apply. Right? Apply takes in x and y, and it just returns the sum of x and y. Right? So there's my method. Right? There's the definition of the method. Right? It just returns the sum of x and y. Right? For subtraction, we have the same method. Right? Takes in x and y and just returns the difference. Right? For multiplication, we return the product. Right? And for division, you return the quotient. Right? Each constant gets its own version of the method. Right? Now to do this thing, you have to declare what's called an abstract method. Right? So here we have our method apply. Right? It returns a double, takes in 2 doubles, but it's also marked abstract. Right? So an abstract method is a method that has no definition. Right? So when you declare an abstract method, right, it has no body, so there's just a semicolon here. So when you declare an abstract method for an enumeration, you're saying each one of the constants is going to provide its own definition of apply. Right? And so for each one of my constants, right, now I have to define what does apply do for one of these constants. Right? So this method down here, so the declaration of the abstract method simply says each constant has a method called apply that returns a double and takes in 2 doubles. Right? Now it's the responsibility of each constant to provide the actual definition of the apply method. Right? And so now you've got a little enumeration that represents the arithmetic operations on a simple calculator. Right? And you can use each one of the constants. Using one of these constants, you can call its apply method, and it will do the appropriate mathematical operation. Right? So if you have the constant plus, you always get addition. If you have a constant minus, you always get subtraction, and so on and so on and so forth. So that's kind of cool. Right? We're not actually going to use that in this course, but it's useful to know that it exists. Right? All right, so when should you use these enumerated constants? Right? So basically, if you are representing a class and you realize that hey, there's really only a fixed number of these, a relatively small number of fixed constant objects, right? Then you should probably consider using an enumeration. Right, so all the examples on the first slide, those are probably reasonable places where you would consider using an enumeration. Right? There's another common place where you might consider using an enumeration. So there's a lot of classes that have a bunch of, have potentially a lot of optional values, right? So things that are either on or off or something like that. Right? So one way to implement these types of classes is to have a whole bunch of fields that are of type Boolean. Right? So these are some simple examples. Right? So here I've got binary digit class. So binary digit is either 0 or 1. Right? You might provide a constructor. You might consider providing a constructor where people pass in the value of the binary digit as a Boolean value, right? True or false. So presumably 1 will be true and 0 will be false. Right? Similarly, you might have a class that represents a thermometer, right? Where there's, it can be either in Celsius or in Fahrenheit, right? And so you might pass in, you might consider implementing a constructor that has a Boolean variable called scale, right? Where true corresponds to Celsius and false corresponds to Fahrenheit. Now the problem with this sort of thing is that, so for binary digit, it's not so bad, right? If you write new binary digit true, most people are probably going to assume it's 1. The problem is if you write new thermometer true, who the heck knows what that means, right? It's very confusing reading that code and trying to figure out, so what is this thermometer object going to do, right? If instead you created a little enumerated constant called temperature scale, right, and you have two constants, Celsius and Fahrenheit, right, well, now it's dead obvious what these mean, right? This is obviously a thermometer that measures temperatures in Celsius, right? That's obviously a thermometer that measures in Fahrenheit, right? This is obviously a binary digit whose value is 1, and this is obviously a binary digit whose value is 0. Right? And so using enumerated constants for Boolean parameters makes your code a little bit easier to read. All right, so when you're using, when should you use an enum, right? When you have a set of constants whose values are known ahead of time. Right? All right, so let's look at very quickly a more concrete example here. All right, so this is a card that represents, this is a class story that represents a standard playing card, right? So it's a standard 52 card French deck, right? So here you have the cards 2 through ace, right? Whose rank is 2 through ace, and whose suit is one of diamonds, hearts, clubs, or spades. Right? So before today's lecture, if I'd asked you to implement this class, right, many students would create a card class, and they would probably choose to represent the rank as a string, possibly as an int. Right? For the suit, most students would pick a string. Right? So again, hearts, diamonds, clubs, or spades. Right? And, the rank 2 through ace. Right? So if you implement the class this way, it becomes really annoying very quickly. Right? So first of all, for the rank, you have to decide what are the valid ranks. Right? So my valid ranks are going to be the strings 2 through A, right? Where A is ace, K is king, Q is queen, J is jack. Right? And then you need to keep track of the suits. Right? So the valid suits are clubs through spades, all in uppercase. Right? So there are my valid strings corresponding to the ranks and suits. Right? If someone wants to make a playing card, right, they're going to pass in a rank and a suit. And now what's the problem? Right? They can pass in any rank. They can pass in any string for the rank. Right? They can pass in any string for the suit. So now what do you have to do? Now I have to validate the rank and suit. Right? Turns out it's not so bad if you happen to know that list has a contains method. Right? And if you know that arrays has a method called asList that converts an array to a list for you. Right? So here I can convert my my array of ranks to a list, and then I can ask that list, hey, do you contain the rank that the user passed in? Right? If that is not a valid rank, we can throw an exception. You can do the exact same thing for the suits. Right? Throw an exception if the suit's not valid. Right? If they are valid, you can go ahead and assign this rank and this suit to rank and suit. Right? And you're going to have to do this everywhere, right, where one of your methods takes in a rank or a suit. Right? Because anybody can pass in, because someone can pass in any string for the rank or suit. And this gets annoying very, very quickly. Right? There's another problem too. If you want to print out, here's a method that returns the color of a suit. A color of the card. Right? So now what do you have to do? Well, now I have to look at the suit of the card and decide whether or not it's a heart or a diamond. Right? So if it's a heart or a diamond, I can return red. Otherwise, I can return black. Right? So this is annoying. Right? Everywhere you want to do an operation involving a rank or a suit, you have to look at the rank or suit and then choose the action based off that rank or suit. Right? If you remember that there's only a small number of ranks and suits, right, it becomes much easier to implement this class if you use an enumeration instead. Right? So you can make a rank enumeration whose values are simply 2 through ace. Right? And you can make a suit enumeration whose values are simply clubs through spades. Right? And for the suits, I can keep track of the color. Right? I have another enumeration called color. These are the colors of your cards that are simply black and red. Right? So for the suits, right, I can remember or I can set a field that corresponds to the color for each suit. Right? So call a constructor. There's my private field that is a color. Right? There's my constructor that sets the color for a card. Right? If I want to know what the color for a card is, I can just provide a little method that provides the color for the card. right? And now, when you implement the card class, right, it's dead easy, right? I have a rank field for the rank. I have a suit field for the suit, right? Look at the constructor, there's no validation, right? I know that the ranks are, I know that I have a rank object to represent the rank. So I know for sure the incoming object is valid, it's a valid rank, right? I have a suit object corresponding to the suit. I know that the suit object that's coming in is valid. I don't have to do any validation whatsoever, right? And it's dead easy now to implement the constructor. What about the color, right? So the color method, right? The suit knows its own color, so I can just ask the suit for its color, and you're done, right? So as soon as you use an enumeration for this class, it becomes very easy to implement the card class, right? All of the validation that you used to have to do with strings goes away, right? All of the switching that you would have to do based on the value or the rank of the rank or the suit of the card, that all goes away, right? You just ask the constant for its color or its rank or whatever other values you're storing, right? And it takes care of it for you. Printing the card is easy too, right? ToString is dead easy, right? Just print the rank. This is going to do rank of suit. So for example, ace of clubs, right? Again, no switching on the strings or anything like that. Right? And so there's an example of using an enum to make your life much easier to implement a class. All right, any questions about enumerations? For the purposes of this course, it would be nice if you could do this, right? So if you can make a simple enumeration, it often makes your life a lot easier. All right, so that wraps up the enumerated, the enums lecture. Okay, so the next lecture is relationships between classes. All right, so far in the course, you've implemented some classes. We know how to implement a class that has fields, constructors, and methods. Right? So for the fields, for most of our classes so far, the fields have been primitive. Right? You have to remember that your fields can also be of reference type. Right? So you can have an object that is made up of other objects. Right? And as soon as that happens, you now might have to consider, right, what is the relationship between all of the objects in my class. Right? So an object-oriented program is made up of multiple interacting classes, right? And the relationship between classes is important. Right? So you can have a class that has fields of reference type, which means your classes are built using other classes. Right? So the structure of your class, right, relies on other classes. Right? So now there's a relationship between your class and its fields, right, and the classes of its fields. Right? Similarly, classes will interact with other classes, right? Objects interact with other objects, and so that's the behavior of your program. Okay, so there's, sorry. All right, so the weakest relationship that you can have between two classes is this thing called dependency. Right? And so dependency models the uses relationship, right? So one class uses another class. So if X uses Y, then we say that X depends on what? Oops, sorry, X depends on. We say that X depends on Y. Right? Now, it can also be the case that Y depends on X, right? So dependency can be two-way, right? Both classes can depend on one another, right? They use one another. Right? So how can you tell if X depends on Y? Right? So if anywhere in the class X, Y appears, then X depends on Y. Right? So where can Y appear? Right? Well, it might be one of the fields of X. Right? It might show up as a parameter in one of the methods or constructors. Right? It might show up parameter. It might show up in the implementation of the method or constructor. Right? So it doesn't necessarily show up as a parameter, but it might be a little local variable inside one of your constructors or methods. Right? And finally, this is actually a subclass. So this is actually a special case of this one here. Right? One of your methods might return an object of type Y, right? In which case X also depends on Y. Hang on just quickly. Okay, so let's take a quick look at an example of dependency. So I want a web. All right, so I'm going to go and find the, sorry. I'm going to go look for the object and string classes. Okay, so let's look at the class big O object. Right, so remember, big O object, that's the every class in Java is also one of these things here. Right. So when you look at the, so here we're only going to look at the documentation for object. We're not actually going to look at its source code. So based only on its documentation, we can ask the question, what classes does object depend on? So object has a method right here. So object has a method that returns a big C class object, right? So big O object depends on the class called big C class, right? There's a method that returns a string. So big O object depends on the class string, right? And based on the documentation, that's all that it looks like big O object depends on, right? If you click on string, and again, only looking at its documentation, right? We can see that string, it looks like it depends on this type called comparator. It looks like it depends on this type called charset. And not surprisingly, there's going to be a, where's equals? Here it is, right? String also depends on the class big O object, right? So remember, object depends on string. So here's an example of a case where you have a two-way relationship between two classes, right? Object and string depend on one another, right? And string depends on a whole bunch of other classes as well, right? So there's locale and so on and so on and so on. Right? So in a UML class diagram, you can show this relationship between two classes, right? You can show the dependency between two classes, right? And so the way that you show dependency in a UML class diagram, so you draw your classes. So here I have point2, string, and vector2. We haven't talked about vector2, but it's a companion class to point2. Right? So point2 has a toString method. And so that means it depends on the class string. Right? Vector2 has a toString method. So it also depends on the class string. Right? And so this arrow, this dashed arrow with an open arrow here indicates dependency. The dash and the open arrow are significant in UML, right? There's a closed arrow, there's a solid line, and there's other types of lines in UML, right? So dash line, open arrow, pointing from the class to the class that it depends on, right? Point2 also depends on vector2, right? It's possible that if you modified vector2, right, so that it also depends, it can also depend on point2. Right, so this relationship here can be a two-way relationship. Right. Although I don't think the implementation of vector2 in the course notes depends on point2. I think it's one way. Okay, so that's dependency. So dependency is uses, right? So the simplest type of relationship between two classes. Association is a stronger form of dependency. So it's dependency, but it means something more. Association means has a, right? So dependency is uses, right? Association has a, right? So X has a Y, and so that means that your class X has a field of type Y, right? If that's the case, then we say that X is an association with Y, right? Now it can also be the case that Y is an association with X, right? So association is also allowed to be two-way. I guess this is, so this is from a previous version of this course. So the class range is basically the same as the class interval that you're implementing in assignment 3, right? It represents a range of values, right? From some minimum value to some maximum value, right? A ranged value is simply a value in this range, right? So in other words, it's a value between some maximum value and some maximum value, right? The range represents all the values in that range, right? A range value represents one of the values in that range, right? So it has a reference to a range, right? And the value inside that range, right? And so range value has a range object. So we say that range value has an association with range, right? Range does not have a range value object in it. So it's not true that range has an association with range value. Right? So to draw an association relationship in UML, it's a solid line, no arrow. Right? So here, range value has an association with range. In these UML class diagrams, you can put what's called a multiplicity element. Right? So the 1 here means that range value has an association with one range. Right? There's only one range object here. Right? So you can put a 1 here if you like. Right? The 1's optional. Right? If you see it in the diagram, though, it's indicating how many range objects does a range value have. Right? It's got one range. Here's a more complicated example of a class diagram showing association relationships. Right. All right, so this diagram is quite complicated to interpret. So you would not be asked to interpret something like this on a test, for example. Star means 0 or more in these multiplicity, when you're listing the multiplicity. So this is showing you the relationship between a class called show and a class called performer. Right, and so this is a pair of classes that you might use to represent something like a Broadway show and the performers in the show, or a concert, right, and the performers in a concert, right, something like that. This relationship here is labeled orchestra. This relationship here is called cast, right? So these would be the musicians in the orchestra, right? These would be the actors or actors and actresses in the cast. Right. So this says that a show object, solid line, so it means association, right? So a show has 0 or more performers, right? A performer can belong to 0 or more shows, right? So the line goes back the other way. Right? A show has 0 or more members in the cast, right? And a performer can be a cast member in 0 or more shows. Notice that a class can have an association with itself, and that's what this line is indicating here, right? And so this line here is for the backup role for a performer, right? So a performer can be the backup to another performer, right? And here you've got the roles of the performers, understudy and lead, right? So a performer might have 0 or more understudies, right? And going back the other way, an understudy can be the understudy for 0 or 1 lead roles, right? It's not usually the case that an understudy understudies more than one lead role. Right? And so there's an example of a class diagram that shows you the association relationships. Right? The important things to take from this diagram are the fact that you can have a two-way relationship, right? You can have show and performer. There's a two-way relationship between these two things here, right? And in an association, a class can be associated with itself. That's probably a good place to stop. And so the next two relationships are a little bit more complicated. Right? And so we'll pick those up. We'll talk about those possibly tomorrow. Right?